Pedigree Chart. Pedigree Chart. One way geneticists can determine if offspring are going to inherit a genetic trait or a genetic disease is by creating a pedigree chart and analyzing the patterns. A pedigree chart is similar to a family tree, except that it also shows whether each person possesses a specific trait, is a carrier for the trait, or does not possess the alleles for the trait. Important symbols. These are the symbols used in pedigree charts. A male is represented by a square, a female is represented by a circle. If the square or circle is shaded, that individual is affected. When there is a line going between the square and the circle, that means there is a mating. And when a line branches out directly from that mating, we have children. And the children below where the parents are the siblings. If the circle or square is half shaded, that means the individuals are heterozygous or carriers. And when there is a line going through an individual, that means that individual is dead. Autosomal traits. An autosomal trait can be exhibited by both males and females. If the trait is autosomal dominant, then every individual with the phenotype for that trait will have a parent with the phenotype for that trait. If the trait is autosomal recessive, then the individual with the phenotype for that trait can have one, two, or neither parent exhibit the phenotype for that trait. Heterozygous versus homozygous. Remember, heterozygous means the individual has different alleles, so one dominant and one recessive. Homozygous means the individual has the same allele, so two dominant alleles or two recessive alleles. If an individual has a homozygous dominant or heterozygous genotype, they will exhibit the dominant phenotype, because remember, that dominant allele is there, so you have the dominant phenotype. If the individual is homozygous recessive, they will exhibit the recessive phenotype, because there is no dominant allele, it's not present, so now we see the recessive phenotype. If two individuals are heterozygous for a recessive trait, they will not show the trait phenotypically, but they can produce offspring that are homozygous recessive and do exhibit the trait. If some of the offspring just happen to not receive the dominant allele, they just receive one recessive allele from each parent, the offspring could exhibit that recessive trait. Autosomal recessive trait. Not all pedigree charts show the heterozygous genotype. If only the individuals who express the trait are indicated, you must infer, based on expression of the trait in later generations, who is a carrier. In the following exercises, individuals who express the trait will be indicated regardless of their genotype. In other words, affected heterozygotes will be marked and unaffected heterozygotes will not be marked, so they will not be half-shaded. Sex-linked trait. If a trait is sex-linked, it is usually only seen in males because most sex-linked traits are recessive and are located on the X chromosome. Therefore, a male receiving an X chromosome with the recessive allele will exhibit the trait, because they only have one X and then the other one is a Y. A female receiving one X chromosome with the recessive allele is a carrier, but will not exhibit the trait because she also has an X chromosome with a dominant allele. A female will only exhibit the trait if she receives two X chromosomes with the recessive allele. She has to be homozygous recessive. If a sex-linked trait is carried on the Y chromosome, then only the males can exhibit that trait. But this is pretty rare. Sex-linked trait. Here we have a cross between a healthy male and a carrier female. The female carries a sex-linked allele, and it's on the X chromosome there, so she is a carrier. And as we can see from the cross, only a male, in this case, will actually have that disorder, have that phenotype, because he is stuck with a recessive allele from the mother, but does not get a healthy X chromosome from the father, because in order to be a boy, he must receive a Y chromosome from the father. The daughters are more fortunate because they can get a healthy X chromosome from the father, if the father is not a carrier, in this case he is not. So therefore we could see that usually it's a male that shows the phenotype for a sex-linked disorder, or an allele on the X chromosome. So according to the genotypes, if it's X, X little r, the female does not express the recessive trait, but for an X(ry), the male does express the recessive trait because he is stuck with that recessive allele, has no dominant allele on another X chromosome. Pedigree chart. X-linked recessive trait. In this pedigree, we have a female carrier. She is XX r, we'll call it. And as we can see from this cross, she has daughters who could be carriers, or daughters who are not carriers. But there is a male who does exhibit this trait. He exhibits the trait because his genotype is X(y). The father is healthy. He does not have this trait. He does not have that X-linked allele. He is just XY. So his Y went to his son, but the mother gave her X chromosome with the allele on it, so the male exhibits the trait. There is no way a female could ever exhibit this trait because no matter what, they get their good X chromosome from their dad. They could be carriers, but they will never be actually affected by this allele.